Hello, dear students. Today we will read battery. Okay. So I hope you all are safe at home and take out your copy, start understanding, start writing the key points, whatever I'm explaining you. Okay. So battery. From the childhood, we know that battery is a small devices where we will produce what? Electrical energy. Okay. So here batteries basically of two types. Batteries are of two types. One is primary cell, another one is secondary cell. Okay. The battery that we are used in a remote or watch, that is your primary cell. How do you know that is primary cell? Primary cell, the characteristics of primary cells are, these cells are non reusable. Another thing is that these cells are non rechargeable. Okay. Another thing is that irreversible. What? Irreversible. Okay. So these are the characteristics of primary cell. Okay. And what are the secondary cell characteristics? Obviously the opposite one. That is what? These cells are rechargeable or reusable. Second is what? These cells are rechargeable. Third is what? It is reversible. Okay. So the watch batteries, double A, triple A battery, that is pencil batteries, like this. So these batteries are normally what? Under the primary cell, and those who are rechargeable batteries like your inverter battery, car batteries, these all are secondary cells. Okay. So what happens normally in a cell? We already read in this chapter that the conversion, what conversion? Chemical energy to electrical energy. Okay. And again from electrical energy to chemical energy. Okay. So chemical energy to electrical energy. So in this primary cell, what happens? Chemical changes, that is the galvanic cell or chemical energy will give electrical energy. Here both the things happens in secondary cell. Okay. So we'll go in details that primary cells, the example of primary cell are, right, example, dry cell. Okay, dry cell. If not, you can also call Lakeland's cell. This is also known as Lakeland's cell. Okay. Next is Mercury cell. Okay, Mercury cell. Or HG cell, huh? So in the secondary cell, examples are lead storage battery, lead storage battery, and simultaneously nickel cadmium. Okay, nickel cadmium battery. Okay, dry cell mercury cell, that will under your primary cell. Secondary cell, which is lead storage battery or nickel cadmium battery. Here what happens, both your chemical chain energy gives electrical energy initially. Okay, while you are charging it, again you are applying electrical energy or electricity to your inverter battery or a rechargeable battery. That will happen inside, something will happen, that is the chemical reactions by which it will store energy. Once while discharging, this energy will change to electrical energy, through which we can light our fan, light, TV, etc., etc. at your home appliances, right? So the example are the lead storage and nickel cadmium. Understood? So let us discuss about the primary cell. Okay. Okay. So in primary cell, dry cell, we'll see. Okay. So dry cell, that pencil battery, that remote battery. Okay. So what is the construction part? Let us check here. I'll make it big. Suppose this is a cell, okay, and you all know this top part is positive this side. If you'll rotate that, you will get to know this side is positive and this is cathode. The end part will be your anode or negative. So this is what primary cell. In primary cell is nothing but your galvanic cell. Galvanic cell, always the positive is your cathode, negative is your anode. Remember, these are very important things. Lone, remember the lone. Left oxidation, anode, negative. So this is what graphite. Okay, this is what graphite, and here a paste is kept, and this is what insulator of zinc. Okay, and inside it what you will get, MnO2, carbon, NH4Cl. The combined paste is applied in this area, okay, or electrolyte. So what will happen here, two electrodes, like it will act as a two electrodes. This is one half, this is again one half. Okay, so this is cathode, this is anode. Okay, zinc. Two things will happen, oxidation and reduction, right? What will happen in anode? Obviously oxidation. What will happen in oxidation? Losing of electron. Zinc 2 plus 2 electron, right? This will happen in oxidation. And what will happen in reduction or at cathodic end? MnO2 keeps rise your Mn OOH, manganite. How it will give? Obviously, Mn is the oxidation state is how much? +4 here. It will go to +3. How? By accepting electron, right? So, and again, how it will form oxide manganese oxide hydroxide? How will it will form? With the help of these ions plus NH plus NH4 plus. Okay, so it will give NH3 again. So once it will convert, it can be reversible, right? So that once it is used, once the all reactions completed, it will not work properly, so that we have to throw it, right? This is what about your dry cell, and the maximum voltage is 1.5 volt, remember. Okay, so next we'll go to the mercury cell. Mercury cell that we are using in a watch battery. Okay, that mercury. Okay, the small one, tiny one. If you opened your watch, you will get to know a small battery is there. Okay, that battery is nothing but your mercury battery, and that is what primary cell. Okay, let's see what is the anode and cathodic reaction over here. So, mercury cell, so this is the small round batteries that has been used in your watch. You must have seen inside your watch. Here the anode is zinc mercury amalgam. Okay, zinc mercury is taken as a anode, and cathode is your mercury oxide and carbon. Okay, and the electrolyte that is being used, electrolyte that has been used is your KOH and ZNO, zinc oxide and KOH. Okay, that has been used as a electrolyte. So what happens in anode? It's very clearly zinc. What will form? Zinc Hg amalgam. When it reacts with these hydroxide ions, OH minus ions, okay, it will give zinc oxide. Obviously oxidation means losing of electron to electron, okay, along with water. So these two electron will carry with this HGO in cathode. Okay, so what happened in cathode? This is what anode or oxidation. Okay, now we'll write about cathode. What happened? HGO plus H2O and 2 electron. It will give what? Hg plus OH. So Hg right? H oxide, here reduction will happen. Zero state, the reduction, losing of electron, gaining of electron. Okay, here it is gaining electron, here it is losing electron, here oxidation happen. This is what? Reduction in mercury cell. The important thing is that you have to remember these anodic and cathodic condition, or anodic and cathodic reactions in these cells. Okay, in mercury cell, what is the anode, what is the reaction occurring in anode, what is cathodic reaction, or in dry cell as well you have to remember that what is the condition or what is the reaction. So this is what the construction part of your cell, how a cell work. Okay, mercury cell or about the dry cell. So next we will proceed towards the secondary cell or lead storage battery. Let me clean these things. So secondary cell is your lead storage battery. Okay, so what is the cell over here? Very simple. Okay, write once anode and cathode. These batteries are usually used in your inverter, right? Car batteries, automobiles battery. Okay, and again lithium ion batteries. Okay, so these will under your secondary cell. Okay, so lead storage battery. So here what happens in anode, I am writing in Pb to PbSO4. It converts Pb to PbSO4. Okay, in cathode it also PbO2 to PbSO4. Okay, PbO2 to PbSO4. The important thing in between these, we are giving H2SO4, that is 30%. Okay, concentrated 30% concentrated H2SO4 is given for the ionic mobility, right? So what happens in anode reaction? What happens in anode? PV is getting PbSO4. Okay, how? Simply Pb to PbSO4 means it losing 2 electron, right? And where it is getting that SO4 plus SO4 2 minus. From where it is getting this? From H2SO4, right? From H2SO4 it takes this SO4 2 minus and it will convert to PbSO4 by losing 2 electrons. Okay, that 2 electron, this is anode, that 2 electron in cathode, what happens? That 2 electron PbO2 plus this 2 electron will giving this PbSO4 again, right? So how it is giving that PbSO4? 2 electron, again it combines with this SO4 2 minus. Okay, you need to balance all the time. Okay, these reactions you need to balance. Okay, now see, if you let 4H plus here H2O, 2H2O. Okay, 4H plus. So what will be the overall reaction? Overall reaction, what you are getting? see this 4H plus and this is your H2SO4, right? H2SO4, that one is. So you can write this Pb, this SO4, SO4 2 minus and H2SO4 plus PbO2 plus 4H plus means 2H2, right? 2H2SO4. Electron cancel. Okay, so it is 2PbSO4 plus 2H2O. Okay, so this is what your reaction. Okay, while it is charging, this reaction happens. Sorry, discharging. While charging, reverse, you need to apply plus electricity. You must mention this plus electricity. Okay, once this reaction happens, you will get these things along with electricity, right? Once this electricity means, once the reaction completes, what happens? You need to charge your battery, and at that moment you have to apply electricity, and that electricity, and again this reaction happens in that side, and it will come to this side. So that is what your electrolytic cell. Initially one is galvanic cell, this one is electrolytic cell. This is what about your secondary cell or lead storage cell. The efficiency of lead storage cell is quite high as compared to your nickel cadmium cell. Okay, similar type of nickel cadmium you can also use, but these batteries, nickel cadmium battery, is very expensive, and for that reason we are not at all using that nickel cadmium cell. But lead storage is very familiar to all of us, so we are using heavily inside your home, in vehicles, as well as because of this expensive and the because of the low expensive and the what efficiency. Okay, this is all about your secondary cell. So I am again telling nickel cadmium battery is also a secondary battery, and though it is very expensive, we all not use these battery secondary cells, but the power consumption or the performance is better in case of lead storage battery, and so we are using lead storage battery. Okay, so we'll not go details of this because you don't have in your course. Okay, let's move towards the fuel cell. Okay, dear students, fuel cell is very important nowadays because we know that in thermal power, how we are generating electricity by hydrothermal projects. Okay, we are applying water, convert by chemical reactions. We are use it in turbine. The spinning of turbine will be high, and after that we are generating electricity. But we have such device by which we can easily convert these things in a electricity. That is what galvanic cell. Okay, chemical energy will give the electricity directly, so there is no need of these things, right? But yes, that is how we will use this galvanic cell for making water and for making electricity. That is what fuel cell. Okay, use of galvanic cell or the energy of combustion into the electricity is your fuel cell. Let me clean these things. Okay, fuel cell. Okay, as I told that we will design a galvanic cell where the combustion will give you that electricity. Okay, write the definition. Fuel cell, the galvanic cell, that converts or that designed to convert, is it visible? Okay, that designed to convert the energy of combustion, that energy of combustion, okay, combustion of what? Combustion of fuels such as fuel क्या है? मीथेन, लाइटिंग आ रहा है ना, ओके, such as मीथेन, इथेन, butane, हाँ. So these are the combustible materials, combustible fuels, right? Such conversions or methanol, if you are taking, etc., directly, कहाँ से कहाँ तक? Directly to the or directly into your electrical energy, okay, directly to the electrical energy. Such cells or such devices are known as what? Fuel cell. Understood? This is one type of galvanic cell where we will convert the combustion of fuels like methanol, methane, ethane, okay, normal the combustible materials, fuels which are acting as the fuels, they will convert to into the electricity. So basically these fuel cells are highly used in space, okay, where we are using these to purifying water or vapors. See, during this process high steam obtained, okay, we know that steam energy is very much high. So likewise in hydrothermal case we are getting that electricity by applying water. So there will be what? Condensed water will be there, and by or vapor water will be there. That vapor water can be condensed and for useful for the drinking water. So normally astronauts, they are using this fuel cell for to making water from this kind of methanol or ethanol. Okay, they are using this fuel cell for to make drinking water particularly. So these are very important nowadays. Fuel cell is highly used in your space research centers. Okay, so what happen in fuel cell again? So there is the, if you will go to the construction part, this is nothing but about your hydrogen, oxygen only. Okay, so what happen? So there is a cell like this, wall like this, okay. So here water, these are normally these are porous. One side you will apply oxygen, one side will apply hydrogen, okay. Here it will condense and it will give H2O, okay. This is sorry, excuse me. This is what your positive, this is what your negative end. So what happens in anode? Right? O2 plus H2O plus, it will give what? It will give 4, okay. This is what your cathode happens, not in anode. Cathode, because electron, it accepts electron. Okay, what will happen in anode then? Similarly, तुम्हारा H2 4OH, this 4OH will give you that H2O plus electrons. Okay, simple. The overall reaction, what will happen? 2H2 plus O2 will give you the 2H2O. This is what your overall reaction. This is what your overall reaction. Okay, this is your fuel cell. Next we'll proceed to corrosion. What is corrosion? Basically, corrosion is a coat, right? We all know that rusting of iron, right? That is a corrosion. So corrosion is also useful sometimes because it gives a coat or layer, it forms a layer, sometimes protective, sometimes destructive, right? So corrosion. So if you take a iron, piece of iron, and if you keep in atmosphere condition, someday will become rusting of iron will happen. How? See, this is the Fe. It loses irons, electrons. This is pura iron block, and this will combine along with. It will come to Fe2 plus, right? By losing this electron, Fe2 plus it will come. So this Fe2 plus will combine with O2, which is present in water or moisture. It will form iron oxide Fe2O3, which is your corrosion. So these are the basically it coats the surface of a metal object, right, with oxides or other salts. This is the corrosion. Okay, how it happens? In corrosion, the metal oxide formed by losing electrons, right, by losing electrons, and when it combines with oxygen, it forms an oxide. Understood? Clear? Two things will happen. What is the reaction over here? You can write Fe will convert to what? Fe2 plus 2 electron. Solid Fe will convert Fe2 plus, right? This Fe2 plus, what will happen? Combines with this Fe2 plus combines with oxygen. This Fe2 plus combines with oxygen, O2, right? And in aqueous medium, if it is H plus will be there, it reacts with excuse me. Here this for 2H plus again H2 के साथ react करके the conversion of medium will be acidic. Okay, so acidic condition भी होगा. This is what the reaction, how it will neutralize that acidic medium, or overall reaction if you write in this way, then this is nothing but your Fe2 plus aqueous plus H2O. Okay, and what the E value equals to 1.6 volt. Okay, 66663. Okay, so this is about your corrosion or the chapter electrochemistry. Do the exercise. Okay, if any doubt, let me know. I'll explain it again.